to grade 12 mathematics, and our first module that we're going to study is sequences and series, and this is lesson 1 of that module. Let's dive straight in. A lot of this you'll be familiar with, but a sequence is essentially a set of numbers following some form of pattern or rule, and a series is exactly the same idea, although with a series we're adding up the terms of the sequence. So for example, if we've got a sequence 1, 4, 7, 10, then the corresponding series would be 1 plus 4 plus 7 plus 10. For metric maths, there are 3 different types of sequence that we need to deal with. The first is what we call an arithmetic sequence. And an arithmetic sequence is where we get from one term to the next by adding a fixed amount. Right? That fixed amount could be negative. If we look at this first example, each time we are adding 3 to get to the next term. So in fact, the next term here will be 14, then 17, and then 20. Here we are adding 3. With this next one, we are actually decreasing by 4. So we're actually adding negative 4. The next term would be negative 2, then negative 6, and then negative 10. Here we are adding negative 4. In this next one, we're going 2x, 3x, 4x. We're clearly adding an x each time, right? But in fact, the constant piece is actually decreasing by 2. So what we're adding actually is x minus 2. Our next term here will be 6x plus 4, then 7x plus 2, and then just 8x. So here we are adding x minus 2. So there are 2 things which affect an arithmetic sequence. The starting number, start value, which we're going to call A, and the common difference or constant difference, which we'll call D. Okay, D is found by taking any term and subtracting the previous term. When we say previous, we mean the term before it. So for example, D could be term 7 minus term 6. What we're going to do now is we're just going to work out D for each of these sequences here, right? So in this one, we could take any term and minus the term before it. So for example, 20 minus 17 or 8 minus 5. In this one, D is 3. In this one, we take any term and we minus the term before it. So 2 minus 6, D is minus 4. Notice that minus 10 minus 6 would be minus 10 plus 6. It would still be minus 4. Every single difference is constant. And then in this last one, if we take, for example, 3x plus 10, and we take away all of 2x plus 12, we get D equals x minus 2. So D is the constant difference. It's the amount we are adding to get from one term to the next. Right. A very important idea is that if we have 3 numbers, A, B, and C, in arithmetic sequence, then clearly the difference between A and B must be the same as the difference between term 3 and term 2. In other words, C minus B. We've written this in a box. It's a really, really important result, and we'll use it before long. Right, let's turn to the next page. And we know that if we know where a sequence starts and by how much it grows, then we can write down some terms, as many as we like. All right. This one starts with minus 5, and the constant difference is 3. We're going to write down the first 5 terms. So we start off at minus 5. We add 2. So we add 3, the common difference. We get to minus 2. We add 3, we get to 1. We add 3, we get to 4. We add 3, and we get to 7. Notice that we separate the terms with semicolons, not commas, all right, because a comma, we use a comma for a decimal point. The next one, we're going to start at 12, and then we're going to add minus 3. Then we're going to add minus 3. We're going to add minus 3, and we're going to add minus 3. The next one, we're going to start at 4x plus 2, and we're going to add negative x plus 2. We're going to get 3x plus 4. We're going to get 2x plus 6. We're going to get x plus 8. And lastly, when we add negative x plus 2 to this, we're just going to get 10. That's our fifth term. Really important idea now is that we use Tn to denote the nth term of the sequence. So for example over here, if we look at this sequence, is it arithmetic? It's growing by 3, it's growing by 3, it's growing by 1. So the answer is no. It's not arithmetic. It does not have a constant difference. Okay, it does not have a constant difference. But for this sequence, we can still give the third term. And the way we're going to write that is that t with a little 3 equals 8. The term which is equal to 5, well, in fact, the second term is t5. Right, so t2 is 5. Notice that t5, 1, 2, 3, 4, 5, is 11. So really important to distinguish between this little subscript here, which is telling us where the term is, and this here, which is telling us the actual value of the term. The second term is 5. The fifth term is 11. Right. Now, the difference between Tn and n we've spoken about, right? And A is obviously the same as T1. Finally, it's important to realize that in fact, the common difference is any term minus the term before it. Okay, we said that just now. Now we're writing it in symbols. Now we've got a formula for the nth term of an arithmetic sequence. And here it is. It's Tn equals a plus n minus 1 lots of d. Right? We're going to prove this formula, and it's a proof that you need to know for matric. So let's turn over and have a look. We're going to start off with a specific example, 3, 7, 11, 15, and then we'll do a general example. So here we've got T1 equals 3. T2 is actually 3 plus 1 common difference of 4. To get to the next term, T3, we're going to actually add 3 plus a 4 plus another 4. To get to the, so we're just adding 4 to the previous term. To get to the fourth term, we're going to take this term and we're going to add another 3. So instead of having another 4 rather. So instead of having 2 lots of 4, we're going to have 3 lots of 4. Right? And hopefully we can see that by the time, if we, for example, wanted to get to the 9th term, right, the 9th term would be 3 plus, notice that this number of common differences that we add is 1 less than the term number we're trying to find. So T9 would be 3 plus 8 lots of 4. T20, for example, would be 3 plus 19 lots of 4. And clearly, Tn would be 3 plus n minus 1 lots of 4. Right, now that, if we want to, we can actually take the brackets out of that, and we get 3 plus 4n minus 4, which actually simplifies to Tn is 4n minus 1. Now we've got a general rule for that particular sequence. where we can find the nth term by just choosing a value for n. So for example, T3, if we use our formula, will be 4 lots of 3 minus 1, which is 11, 1, 2, 3, there it is. Okay, right, we're going to do exactly the same thing now, but we're going to do it with the general case. Right, so we've got T1 is A, T2 is A plus D. To get to T3, we're going to add another D. So in fact, it's going to be A plus 2D. To get to T4, we're going to add another D. So it's going to be A plus 3D. T12, for example, would be A plus 11D. Notice that the number of constant differences that we add is one less than the term number we're trying to find. And the reason for that is that for the first term we don't add any. So T1 is A plus 0D. And then it's 1D, 2D, 3D, always lagging by 1. It makes sense. Alright, and so clearly Tn will be A plus n minus 1 lots of D. Right, and that is a really, really important formula. We get supplied it in all tests of exams, and now we're going to practice using it. It has 4 variables in it, and in maths, if we've got an equation with 4 variables and we know 3 of them, we can work out the 4th one. Right, so we're going to do a few examples to practice this. First up, we are going to work out the 17th term of this sequence. Let's start off by writing down the formula. Tn is A plus n minus 1 lots of D. Right, so in fact, T17 will be A plus, let's fill in the A value. A is 7 plus 17 minus 1 lots of D. D, remember, is any term minus the term before it. For this one, D is 3. Okay. Right, when we simplify this, we get that T17 is 55. The 17th term is 55. Okay, this next question says, how many terms are in this sequence? Right? So this is a certain term number. What we want to know is which term number. We know what A is, we know what D is. So in this formula, Tn equals A plus n minus 1 lots of D. We actually know this, we know this, and we know this. What we don't know is which term that is, how many terms there are. So we're going to put that in over here, -7. A we know is 35, plus n minus 1 lots of D, and we know that D is -3. Right, now we just need to solve this equation. Remember, an equation is just like a set of scales. Whatever we do to one side, we must do to the other. Let's subtract 35 from both sides. All I've done here is I've written this in a different order. We now have a choice. We can either multiply this -3 into the bracket, or we can divide both sides by -3. It's actually going to be slightly quicker if we divide both sides by -3. When we divide -42 by -3, we get positive 14. That's an integer idea. Remember, negative divided by negative is a positive. Positive 14 is n minus 1. The last thing I'm going to do to solve this equation is I'm going to add 1 to both sides. So in fact, n is 15. All right. So therefore, there are 15 terms. And in fact, this term over here is -7. So T15 is -7, the 15th term. Okay, right, let's do another one. And this time we're going to be missing a different variable. All right, this one asks the first term of a sequence which has that common difference, and we know that the 17th term is 55. All right, let's have a look. So we've got our formula, Tn equals A plus n minus 1 lots of d. All right, and we know that the 17th term is 55. In other words, I'm going to put 55 here. I'm going to put 17 in here. I know the common difference is 3. I'm actually going to write it at the front here, and I don't know a. We just have one variable that we're trying to find, elilodwa. All right, so now let's simplify what's in the bracket there. We've got 16. 16 times 3 is 48. So a plus 48 is 55. And in fact, let's now subtract 48 from both sides. And if we subtract 48 from both sides, we get 7. So this sequence starts with 7 as its first term. Right, let's have a look at this one. Determine the common difference of a sequence which has that as the first term and T21 is 46. Let's have a look. Tn is a plus n minus 1 lots of d is our formula. Right, I know that T21 is 46. So in fact, in this formula, I know a term, I know which number term it is, and I'm told the first term. So there's only one variable that I'm still looking for, and that is d. Right, we're going to write 46 as our nth term. A, we know is minus 4, tells us over here. All right, plus n, sorry, this is the 21st term, so it's going to be 21 minus 1 lots of d. Right, and again, there's only one variable that I don't know here. I'm going to add 4 to both sides, giving me 50 equals 20d. And lastly, I'm going to divide both sides by 20, and I get 2.5 as my common difference. Okay, the next question says, is 150 a term in this sequence? So what I could do is I could just carry on writing down all the terms and see if I get to 150. That would be quite tiresome and quite laborious. Let's rather try and do it with a formula. We know that Tn is a plus n minus 1 lots of d. What I'm going to do is I'm going to work out which number term is 150. So this is Tn, and I'm going to work out which value of n gives us that term. I know a and I know d. So I know this, I know this, and I know this, and I'm going to try and find n and see which number term it is. All right, let's go. Right, so this is going to be 150. This is going to be a is 5. N I'm not sure of at this stage, and I'm going to work out. And d is 3. I'm going to write the 3 over here. Right, let's divide both sides by, let's subtract 5 from both sides. Okay, and so what I'm going to get is I'm going to get 145. And that I'm also going to multiply this 3 into the bracket. Remember, it needs to distribute and multiply by both terms inside the bracket. 3n minus 3. I'm now going to add 3 to both sides. 148 is 3n. And lastly, I'm going to divide both sides by 3. And when I do that, I don't get a whole number. I get 49 1/3, or 49,333. Now, because I haven't got a whole number, all right, there's no 49 1/3 term, right? So the answer here is no, right? 150 is not a term. It's not in the sequence, all right? And the reason being is that n, our term number, must be a natural number. Now the natural numbers are from 1, the whole numbers from 1, 1, 2, 3, 4, 5, all right? I'll just quickly make a little side note to that. These are the whole numbers, whole positive numbers starting from 1, 1, 2, 3, 4, etc. Now in this case, n is in fact not a natural number. And because of that, it's not a term in the sequence. Right, question number 6. How many terms are in this sequence? Right, let's try this one. We're going to write down our formula. Tn is a plus n minus 1 lots of d. All right, and so we want to know which term number is equal to 103. So again, I know this, I know A, I know D. What I don't know is N. Okay, so let's put them all in. We've got 103 over here equals A is 502 plus N minus 1 lots of D. Now, D, remember, is any term minus the term before. So in fact, in this case, D is minus 7. I'm going to subtract 502 from both sides. Remember, I'm trying to isolate N. This 502 doesn't have an N in it. Let's subtract it from both sides, and I get minus 399 is negative 7 lots of N minus 1. We can choose now. We could either distribute this in here, all right? But in fact, it will be simpler to divide both sides by minus 7. And if I divide both sides by minus 7, I get that 57 is N minus 1. Finally, I'm going to add 1 to both sides. So in fact, N will be 58. So there are 58 terms. Okay, notice we're just using one formula and we're just engaging with it in different ways. And that brings us to the end of our first lesson.